Hi and welcome back to the channel. In this tutorial I will introduce you to our first calculus application, that is differentiation. What is differentiation? Well, differentiation is a fundamental process that calculates the instantaneous rate of change of a function or the exact gradient of a curve at any point. Next, I ask, what is the use of finding the gradient of a function? Well, much in every way. Let's consider a practical application by looking firstly at the linear function displayed on the graph with the distance d travelled on the vertical axis and the time taken on the horizontal axis. You should recall that the average velocity of an object is the distance travelled divided by the time taken. So, if we were to find the velocity in this case, we would simply need to find the gradient of the line. If we are given a point on the line, say 1070, the gradient is found by m equals y2 minus y1 over x2 minus x1. Substituting our values in, y2 is 70, so m equals 70, y1 is 0, x2 is 10, x1 is 0. This gives us 70 over 10 equals 7. So our velocity is 7 meters per second. Because this line is linear, the velocity is constant. Now, what if we had a function as a curve representing the distance d travelled against the time t taken? Well, the gradient cannot any longer be found by means of the first example. Consider the graph with the curve d equals t squared. For any t value, the distance travelled is the time squared. That is, at 2 seconds the distance is 4 meters, at 3 seconds 9 meters, 4 seconds 16 meters, and so on. Because the graph is no longer linear, the velocity is not constant, but changes for each value of t. To calculate the velocity, we then need to use differentiation. For such a function of the form d equals at to the power n, the gradient is found by v equals ant to the power n minus 1. So, for our example, d equals t squared. So we have d equals t squared. A is simply 1 because the coefficient in this case is 1. N, the power is 2. So all we do is our gradient is v equals, bring the power down to t. So our gradient for the velocity is v equals 2t. So if we want to find a value of the velocity, let's just choose some t values. So if t equals 2 seconds, v would equal 2 times 2 equals 4 meters per second. If t was 8 seconds, the velocity at 8 seconds would be v equals 2 times 8 equals 16 meters per second. If t were 12 seconds, v would equal 2 times 12 equals 24 meters per second. So as you see, as we go along the t-axis, the velocity becomes greater and greater. Thus far, I have taken you through a practical application using time t and distance d to demonstrate the use of differentiation. However, most commonly, you will be using differentiation using x and y values. So, from now on, everything will be given in y's and x's. So please take note of the amended formulas shown at the top of the screen. I've also not taken you through the theory of how exactly we get the gradient of the curve up to this point, but now I will demonstrate. Consider the function y equals x squared. We see that there are 2 points on the curve, P and Q. P has coordinates xy and Q has coordinates x plus delta x, y plus delta y. We then draw a chord connecting these two lines, like so. The gradient of the chord is therefore delta y divided by delta x. Our aim is to reduce point Q to as close to point P as possible. This means delta x tends to 0 because it gets smaller and smaller. The aim is to find the ratio delta y divided by delta x algebraically. So let's start by doing this. So let's write out the equation y equals x squared. Let's label this as equation 1. Next, using y equals x squared but substituting in point Q, we have y plus delta y equals x plus delta x squared, and this is equation 2. Next, let's subtract equation 1 from equation 2. So y minus y eliminates the y, so we're left with delta y equals x plus delta x squared minus x squared. Now let's expand the brackets, so we have delta y equals x squared plus 2x delta x plus delta x squared minus x squared. So x squared minus x squared eliminates the x squared, so we're left with delta y equals 2x delta x plus delta x squared. Now let's divide through by delta x, which means we get delta x delta x delta x. So that cancels, that becomes 1, and we're left with delta y over delta x equals 2x plus delta x. So because delta x tends to 0 and becomes such a small number, it is no longer needed to be included, so we can just ignore that, which leaves us with delta y over delta x equals 2x. But we write this as dy by dx equals 2x. And just to take your attention again to the formulas at the top, we have dy dx equals an x to the power n minus 1. So using that rule of with the equation y equals x squared, this becomes dy dx equals 2x. So there you have the matching differentials.